Good people, Sanbonani, Makebalo. Today, we'll be doing calculus. We are still on that part or on that question from Bumalanga, the May-June question paper. Remember, we are preparing for our trial exam. So now, let's get into it. This was question 6, which is the first part of it, which is deal with the first principle. So we need to derive using the first principle. First, we need to write our general formula to derive for first principle. It's f at x is equals to lim h approaches 0, and then f into x plus h, and minus f at x into h. Now, first thing here, I'm just going to start by doing this first part here outside, where h into x plus h is equals to 2 minus 3 into x plus h whole squared, and then equals 2. And then from here, we're going to say 2 into 3. And then we're going to simplify this one in terms of the two brackets. And I'm going to have x squared plus 2xh plus h squared. And from here, we have 2, and then we times by these 3 all out. So we're going to have negative 3x squared, negative 3 times 2xh is going to be negative 6xh, and then we're going to have negative 3h squared. This is what we are having here. And then now let's come back to this one in order for us to substitute. So it's f prime of h into lim h approaches to 0. Now in terms of my f into x plus h is this one. So we are going to have 2 minus 3x squared minus 6x h minus 3h squared, and then minus this minus here, minus into my f at x, which is 2 minus 3x squared, and then all over h, and then lim h approaches 0. And then we're going to have 2 minus 3x squared minus 6xh minus 3h squared, then minus 2 plus 3x squared. Then from here, I'm looking for the like terms. So the like terms that I know here, this one is going to have to cancel this one. And yeah, let it. And then I'm going to have only 2 minus 6h. And then, oh, remember, 2 also cancels 2. Yes, 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 yes. And then what is left here is f at x, then lim h approaches to 0. So I'm left with negative 6xh minus 3h squared all over h. Then from here, I have a common factor of what? Of OH. Now equals to lim into OH approaches to 0. Then common factor of OH, and then I'm left with negative 6x minus 3h all over h. And then this h cancels this h, and then I'm left with lim into h approaches 0 into minus 6x minus 3h. And then from here, we substitute our 0 into h, so it's going to be negative 6x minus 3 into 0, and then I have the negative 6x. This is my first principle. Now let's go into the second part of calculus, where we are deriving. Remember, when you're deriving here, we're just using the rule of a derivation, which is the power rule. Now let's get into 6.2.1. So f at x is equals to, this thing is more or less the same as negative. It's half into x into 4, then plus x into 0, then minus pi, and then c2. Now here we need to derive this in terms of x. So if you're deriving this in terms of x, remember anything raised to 0, it's 1. So this is 1, it's just a constant. And pi is just a number. And remember, deriving in terms of x, so anything that is not x, we're going to take it as a constant, which is just a number. So whatever that you are going to derive here, it's going to be this 4 times this half here, which is going to give me 2 into x3, and then these are just a constant, and also this one is just a constant, so it's going to be plus 0 minus 0, which is my derivative is going to be 2 into 3. I hope we're on the same page on that one. Now let me just write my 6.2.2 here. So my dx is going to be negative 3x cubed plus a cube root x squared all over x squared. So I need to derive this. First thing that I need to do here, I need to separate this into 2. So it's going to be dx into negative 3x cubed all over x squared, and then plus this thing here is just the same as x into 2 over 5, and then all over x squared. Then from here, my dx is going to use the exponential rule where this x cubed is going to minus x2 of this, so you're going to be left with negative 3x. Then from here it's going to be plus x, then 2 over 5 minus 2 in terms of the power rule of the exponent, and then it's going to be 3x plus, and then 2 over 5 minus 2, we are going to have negative 8 over 5. So now deriving this one is just going to be 3, which is minus 8 over 5x into negative 13 over 5. And you can leave your answer like this. You're going to get your full 4 marks. Now, let's get into the last one here, which is 6.2.3, where we are having y is equals to 8 cubed minus 1 to 5 all over 2x minus 5. So now in order for us to derive here, we can't derive while we're having fractions like this. So we need to simplify what I have here. This is different of cubes. So I need to factorize this different of cubes. Remember here, I still need to say 2x minus 5 into 4x squared plus 10x plus 25. This is how we derive the difference of 2 cubes, and then all over 2x minus 5. Now 2x minus 5 cancels 2x minus 5, and then my y here is just going to be 4x squared plus 10x plus 25, and then deriving this is just going to be my dy over dx, which is just going to equals to 8x plus 10, and then this is my derivative. Thank you so much guys for watching. Don't forget to subscribe. Makebalo.